Good afternoon to all of you.
Good afternoon, sir.
So we will start within 2 minutes. This PPT is visible to all?
Yes.
Yes, sir.
Yes, sir.
Okay. So I think we have last lecture just on the words. complete this initial introduction part, and I think we have stopped here. Is it right? First chapter syllabus. So have you written all these things?
Yes, sir.
Yes, sir.
Okay, very good. So as I have instructed you or told you in last lecture, in continuous assessment process, you start writing and completing these things in your notebook. So I hope that now everyone is having one notebook of 200 page and you have written the details. That is first page your introduction, then afterwards this syllabus, in that unit number 1 semiconductor physics. And have you written these points?
Yes, sir, written.
Okay, good.
Yes, sir.
Yes, sir.
Okay, no problem. So let us start discussing our syllabus points. So first unit or chapter is semiconductor physics. So you can easily guess from its title that it is related to semiconductor material, but it is not only related to semiconductor material. It includes some other points, that is Fermi level, then derivation of Fermi level, then position and effect of intrinsic and extrinsic semiconductor impurity on Fermi level. Then last one is one derivation which is called as Hall effect and its applications, of course, numericals on this chapter. So all these points are there. So we start with one question. So you just unmute yourself and you can tell the answer. Or if crowd is there, then you can raise your hand. I will select anyone. So can anyone define what is meant by semiconductor material? Semiconductor. Rajakta. Hello.
So, materials in between good conductors and bad conductors, that are semiconductors, that have greater than conductivity of bad conductors and less than the good conductors. They are used to repairing various devices, semiconductors.
Okay. Then any other student? Okay, so this is about the semiconductor. So let us first try to understand that why we are defining these things as semiconductor, or that material as semiconductor. Different definitions are there. Conductivity of that material lies between insulator and conductor. Then we know that semiconductors are the materials which are behaving differently with temperature also. Is it correct?
Yes, sir.
Okay.
Yes, sir.
So first thing is to understand how we can define that as a semiconductor. For that, we have to know band theory of or formation of energy bands related to that solids. And from that, we are classifying the solids. So if we consider the formation of energy band, because you know that we are simply drawing the figures of insulator, semiconductor and conductor, in which we are showing some bands. You know that you can easily recall, that is valence band, conduction band and energy band gap. Is it correct?
Yes.
Yes, sir.
Okay, so what is meant by that valence band, or what is meant by that conduction band, or how we are defining that as a band? So that concept is important one. And once you know that concept, that is formation of energy band, then the next point you can get it easily. So let us shift to first slide of this syllabus of first one. So listen carefully. So on your left side, if you see an individual atom is there, Atom means you know that nucleus, and around that nucleus electrons are revolving in certain permitted orbits. By energy levels, we can show like this below one, that is 1s2, 2s2, 2p6, 3s1 or 3s2, etc. Depends upon its complete or partially filled bands or levels. So this is in case of single atom. Okay. Just show you something by drawing. Okay, now you can see these are energy levels for a single isolated atom. Now you know that solids are nothing but group of atoms or bunch of atoms. Means before moving to this, let us go progressively towards this figure. So for single atom, these energy levels are there and electrons are present in that. Okay, so above energy levels are also there, which are partially filled or empty. Okay, so if we see these energy levels, this is for single atom. Now consider another atom which comes close and interact with this atom. So that atom is also having its own energy levels. Okay, now consider another atom. Okay, so they are also interacting with each other. Okay, so if we are adding number of atoms which are close to each other and they are interacting with each other, then what happens? For single atom, there is a single energy level. But for group of atoms where we can call it as a solid, what happens? There is a set or series of energy levels. There is a set or series of energy levels, and that set or series of energy levels is called as energy band. Are you getting this?
Yes. Yes, sir.
ठीक आहे. थोडक्यात काय तर एक सिंगल ॲटम जर आपण घेतला तर त्याच्या एनर्जी लेवल्स असतात. बरोबर आहे. पण अजून एक ॲटम त्याच्या क्लोज आला, ऑफकोर्स ते एकमेकाला इंटरॅक्ट करणार. अजून ॲटम क्लोज आला, ते एकमेकाला इंटरॅक्ट करणार. तर त्यांच्या एनर्जी लेवल्स आहेत तर त्या तिथं आपल्याला दिसतात आणि त्या जे एनर्जी लेवल्स आहेत त्याचा ग्रुप तयार होतो. तर तो जो ग्रुप आहे किंवा तो जो बंच आहे त्यालाच आपण इथं काय म्हणतो, एनर्जी बँड, जो आपण इकडे दाखवतो. तर इथे जेव्हा आपण अशी फिगर दाखवतो तर याचा अर्थ काय, तर याच्यामध्ये या सगळ्या एनर्जी लेवल्स आहेत. लक्षात येते हे? म्हणजे काय, तर जेव्हा आपण सॉलिडला सेमीकंडक्टर मटेरियल असेल किंवा सॉलिड मटेरियल असेल, कंडक्टर मटेरियल असेल, तर जेव्हा आपण त्याची कंडक्टिव्हिटी डिफाईन करतो किंवा एक्सपेरिमेंटली काही गोष्टी प्रूव्ह करायला जातो त्यावेळेस आपण तिथे सिंगल ॲटम कन्सिडर करत नाही. तिथे आपण काय करतो, वी आर कन्सिडरिंग दॅट सॉलिड ॲज होल, मीन्स दॅट बंच ऑफ or group of atoms at a time we are considering, and that's why we are taking help of band theory. So this is a formation of energy band, means how energy band gets formed, that we are discussing. Are you getting this point?
Yes, sir.
Yes, sir.
ठीक आहे. म्हणजे काय की आपण जेव्हा क्लासिफाय करतो सॉलिडला, ठीक आहे, कशामध्ये, इन्सुलेटर, सेमीकंडक्टर, कंडक्टर, हे सगळ्यांना माहितीच आहे. त्यानंतर त्यामध्ये आपण व्हॅलेन्स बँड पण लिहितो, कंडक्शन बँड पण लिहितो. पण हे बँड्स, हे कन्सेप्ट कुठून आले, तर त्याचा बेस आहे फॉर्मेशन ऑफ एनर्जी बँड्स. तर या फॉर्मेशन ऑफ एनर्जी बँड्स वरून आपण काय करतो, तर याला डिफाईन करतो. नेक्स्ट, now everyone know all these things, that is semiconductor materials are divided into two types, intrinsic and extrinsic semiconductors. Intrinsic means pure semiconductors, extrinsic means impure semiconductors, where further we are defining extrinsic into p type and n type semiconductor. Okay, so intrinsic means what? Pure semiconductor. Semiconductor materials are fourth group element, that is valency is 4, so they belongs to fourth group element. They are trying to complete the octet by sharing the neighboring electrons, and by completing the octet we are having 0 electrons to interact. Means when we are considering the below room temperature condition. So in that case, this intrinsic semiconductor acts as an insulator. Is it correct? Okay, so this material behaves as an insulator when room temperature or above room temperature condition takes place. Then in that case, these atoms are these electrons are breaking the bonds and they are shifting from valence band to conduction band. We are getting some conductivity which is not as much that compared to conductors. That's why these materials are called as semiconductors. Okay, so depends upon temperature, its conductivity property changes. Now, only intrinsic semiconductor is of no use. So for that, what we have to get? We have to get the impurity or doping process. From that, we can get some of the electron hole pair combinations. So here, to increase the electron hole pair combinations, what we are doing, we are adding that particular impurity in that intrinsic semiconductor. So we are, just a minute, what we are doing, so we are taking substrate of semiconductor material and on that we are pouring the impurity. For example, this is P type and for example, this is N type. So by using the pure semiconductor as a substrate or platform, we are adding the impurity or doping materials and we are getting extrinsic semiconductor. Okay, so you know that P type and N type, how we can get. So P type is nothing but trivalent impurity, N type is nothing but pentavalent impurity. So in case of N type, pentavalent means we are getting one loosely connected electron extra, and P type means trivalent. Trivalent means 3, means there is a deficiency of electron. So there is a formation of hole concept. And majority charge carriers are holes in P type. In case of N type, majority charge carriers are electrons. Is it correct?
Yes,
Yes.
sir.
Yes, sir.
So all these things we are discussing to complete the background of our chapter plus the new things. Now here, if you see this figure is visible clearly.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so I try to maximize that so that you can get the good view. आता इथे जर तुम्ही बघितलं तर दोन टाइप्स जे आपण आता डिस्कस केले त्याचेच फिगर आहेत. आता यामध्ये फक्त आपल्याला काय दाखवायचंय, तर जेव्हा आपण इम्प्युरिटी ऍड करतो तर तिथं लेवल्स तयार होतात. ठीक आहे, त्या लेवल्स आहेत ते दाखवण्यासाठी या फिगर आहे तिथं. तर जर तुम्ही एन टाइप पहिलं एक्झाम्पल बघितलं लेफ्ट साइड पिंक कलर. So in this N type, we know that we are adding pentavalent impurity, and due to that pentavalent impurity, there is a formation of energy level, which is called as donor level. इथे तुम्ही बघू शकता pink color, which is just below conduction band. Okay, so this level gets formed just below conduction band, and these electrons are easily available in the conduction band. So this donor level is formed because of pentavalent impurity. Then in case of P type, we are adding trivalent impurity, that is accepted impurity also called. So it is just above valence band. Okay, and here there is a formation of holes because these electrons are trying to jump and occupy this, and then they are moving further towards conduction band. So it depends upon N type and P type, different levels are there. Now, why we are discussing this? Because when we start considering our next point, that is Fermi level. So during that, we are defining this or taking reference of this donor level and acceptor level. तर त्याच्यासाठी हे points आपण discuss करतो. Okay, now we come to the normal point, that's classification of solids. So I hope everyone is familiar with these figures. Everyone know these things. So now you can understand it in better manner that what's meant by band, how this band gets formed. Okay, and the energy levels in valence band, energy levels in conduction band, that is forming these bands and whatever the gap between these two group of energy levels is nothing but called as energy band gap, or it is also called as forbidden band. तर आपण त्याला फक्त नाव देतोय बँड म्हणून, फॉरबिडन बँड म्हणून. ऍक्च्युली तो काय तर गॅप आहे कशामधला, तर व्हॅलन्स बँडच्या एनर्जी लेवल्स आणि कंडक्शन बँडच्या एनर्जी लेवल्स. यू कॅन इझिली guess that how or why we are classifying solids into these three types. Insulators energy band gap is more here, that's why conductivity is not there. At certain extreme temperature or certain extreme conditions we are getting some conductivity, that's why these insulators acts as a poor conductors in some extreme cases. Next, semiconductors as compared to insulators energy band gap is less. Okay, so it is here, if we consider 0.5 to 2, then here it is 0.2 to 1.5 etc, and here there is a overlapping. So different levels are there, depends upon we are classifying the material. आता इथे सेमीकंडक्टर मध्ये जर बघितलं तर इन्सुलेटरच्या कंपॅरिझन एनर्जी बँड गॅप कमी, त्यामुळं आपल्याला इथं कंडक्टिव्हिटी म्हणजे इलेक्ट्रॉन्स जो फ्लो आहे कंडक्शन बँड मधला तर तो याच्या कंपॅरिझन जास्त मिळतो. But it depends upon temperature condition once again. That's why we are considering this as a semiconductors. Now, in case of conductors मध्ये काय होते? So there is a overlapping of valence band and conduction band. So what is meant by overlapping? तर मगाशी जे तुम्हाला मी एक्सप्लेन केलं त्याच्यावरून तुमच्या लक्षात येईल की वरच्या एनर्जी लेवल्सचा सेट आणि खालच्या एनर्जी लेवल्सचा सेट, तर हे जर एकमेकाला क्लोज असतील तर काय होणार, या एनर्जी लेवल्स एकमेकाला काय होतात, खूप जवळ असल्यामुळे इथं ओव्हरलॅप होतात. म्हणजे काय तर हा जो पोर्शन आहे तर इथं बॅलन्स एनर्जी लेवल्स अँड कंडक्शन एनर्जी लेवल्स गेट्स मिक्स्ड, दॅट्स व्हाय वी आर कॉलिंग इट एज ओव्हरलॅपिंग. गेटिंग दिस?
Yes sir, got it.
ओके, तर हे आपल्याला त्या एनर्जी बँड गॅपच्या व्हॅल्यू वरून आपण याला डिफाइन करतो, प्लस नंतर आपण एक्झाम्पल घेतो इन्सुलेटर म्हणजे काय, ग्लास प्लास्टिक असेल, सेमीकंडक्टर सिलिकॉन जर्मेनियम, कंडक्टर्सला तुम्ही गोल्ड सिल्वर कॉपर कुठले एक्झाम्पल देऊ शकता. ओके, सो बिफोर कमिंग टू द नेक्स्ट वन जस्ट आय शो सिलेबस वन्स अगेन. तर याच्यामध्ये आपण काय बघितलं तर क्लासिफिकेशन ऑफ सॉलिड्स, त्यानंतर हे फर्मी लेवल, फर्मी डिरेक्ट डिस्ट्रीब्युशन फंक्शन हे फक्त इक्वेशन आहे आपल्याला, त्यानंतर ही फर्मी लेवल म्हणजे काय आणि त्याचं डेरिव्हेशन आपल्याला बघायचंय, आणि सगळ्यात शेवटी हॉल इफेक्ट. हॉल इफेक्ट मीन्स व्हॉट? सो इफ वी कन्सिडर ए स्पेसिमन, for example if we consider the specimen like this and if we apply electric and magnetic field perpendicular to each other, if this is electric field, if we apply and magnetic field which is perpendicular to electric field, okay, like this, then what happens? Perpendicular to both electric and magnetic field, perpendicular to both म्हणजे कुठला एक्सिस राहतोय, okay, so perpendicular to both, here it is third axis. What happens? Potential difference gets produced and this effect is called as Hall effect. The potential difference which gets produced it's called as Hall voltage. तर याला आपण Hall effect म्हणतो. तर तो नेमका काय ते आपण फक्त डेफिनेशन नाही तर याचं डेरिव्हेशन आहे मोठं, तर स्टेप बाय स्टेप हे समजून घेणार आहोत की करंटची व्हॅल्यू काय, मॅग्नेटिक फील्डची व्हॅल्यू काय, मॅग्नेटिक फोर्स जो आहे तो परत जो लॉरेन्स फोर्स आपण म्हणतो तो कसा बॅलन्स करतो आणि आपल्याला हे हॉल व्होल्टेज कसं मिळतं. And as we are changing the magnetic flux, then how Hall voltage gets changed. So all these points we have to cover during that derivation, its application and numericals on the equation of Hall effect. So all these things we have to cover. Okay. So shall we move to the second one? Okay, so I request everyone that you take screenshot this slide. And if notebook is there, if you have written the first one, so write second, that is unit number 2, crystallography, weightage is 13, and you start writing these points. So I hope that everyone is ready with the notebook. Is it right?
Yes, sir.
Yes, sir.
Okay. Okay. So I will give you 3 to 5 minutes. You have to just write these things. 2.1. You can write. I will dictate and you can continue. No problem. 2.1, introduction to crystal systems. Introduction to crystal systems, comma. Next point, characteristics of cubic unit cell. Characteristics of cubic unit cell. In that, write down. Next point, number of atoms. Number of atoms per unit cell. Number of atoms per unit cell, comma. Next point, atomic radius. Next point, atomic radius, comma. Next is coordination number. Coordination number. So this is 2.1. Then you can continue or you can take next line, no problem. Next is 2.2. 2.2, in that atomic packing factor. Atomic packing factor, comma, void space, VOID, void space, atomic packing factor, that is APF. Then void space, comma, next density of crystal. Density of crystal. Next symmetry elements. Density of crystal. Next symmetry elements. In bracket, there are 3 types of symmetry elements: axis, comma, center, and plane. Axis, comma, center, and plane. Bracket complete. Comma. Next point, Bragg's law, BRAGGS. Bragg's law. Then you can continue, no problem. 2.3, Miller indices. Miller indices, comma, interplanar distance. Interplanar distance. In bracket, by using Miller indices. By using Miller indices, bracket complete. Comma, numericals on this chapter as usual, the last part of the chapter. So everyone write this. So initially we are taking this practice that I'm dictating and you start writing so that it makes habitual to you. Otherwise you are just taking screenshots. I'm sending on the file. And if write tab is remain as it is, then unnecessarily you are lagging behind. So complete all the points in the notebook. Okay, is it over? Shall we start discussion?
Okay, sir.
Yes, sir.
So
yes.
as usual,
Yes, sir.
As usual, we start with the question that can anyone define what is meant by crystalline material? and amorphous material. So I'm asking you a simple question that already you have studied and know to you. Okay, and I'm expecting the response from each and everyone at different stages so that it should be interactive. क्रिस्टलाइन मटेरियल आणि अमॉर्फस मटेरियल थोडक्यात सांगू शकताय किंवा काय फरक असतो, आपण कशामुळे त्याला
crystalline material has definite
crystalline material
arrangement of molecular chain.
Definite shape and volume. Shape and size. Crystalline material have, and amorphous materials do not have definite shape or their shape is not definite.
Okay, so let us go to the next slide. So before this crystalline and amorphous, we are considering the different states of matter, that is solid, liquid, gaseous. We know the different properties of solid, liquid, gaseous. So rigid, fixed shape, fixed volume, solid is having, or liquid, they are not rigid, no fixed shape, but having fixed volume. For gaseous, nothing is there. And plasma state is also there, which is the fourth one. So that are the basic things. Okay, now here comes the answer. So this figure gives you the idea: crystalline solid and amorphous solid. So your explanation is correct, that definite regular arrangement of atoms in 3 dimension, of course, is called as crystalline material, and irregular or random arrangement of atoms is nothing but amorphous material or amorphous solid. So from figure you can easily understand that what is the difference. Next, if we consider, so these crystalline materials are further divided into 7 types, that is called as 7 systems of crystal, and that 7 systems of crystal are further divided into 14 types, which is called as Bravais lattices. Okay, so you can see here introduction to crystal systems जे आपण बघतोय, तर त्यामध्ये आपण हे सगळे पॉइंट्स चेक करणार आहोत. त्यानंतर कॅरेक्टरिस्टिक्स आहेत क्यूबिक युनिट सेलच्या. आता या 7 सिस्टीम मध्ये एक आहे ती म्हणजे क्यूबिक सेल किंवा क्यूबिक युनिट सेल. तर त्याच्यावरच आपला चॅप्टर आहे सगळा, त्याच्याशी रिलेटेड सगळे पॉइंट्स बघायचे आहेत. कुठले कुठले पॉइंट्स आहेत? पहिला आहे नंबर ऑफ ॲटम्स पर युनिट सेल, दुसरा आहे ॲटॉमिक रेडियस, तिसरा आहे कोऑर्डिनेशन नंबर, चौथा आहे ॲटॉमिक पॅकिंग फॅक्टर, पाचवा आहे व्हाईट स्पेस आणि सहावा आहे डेन्सिटी ऑफ क्रिस्टल. हे 6 पॉइंट एकमेकाला कनेक्टेड आहेत, जे कॅरेक्टरिस्टिक डिफाइन करतात क्यूबिक युनिट सेलची. ठीक आहे, त्यानंतर सिमेट्री एलिमेंट्स आपल्याला बघायचे की हेच क्यूब्स आहेत, तर ते आपण सेंटर कन्सिडर करून, ऍक्सिस कन्सिडर करून, प्लेन कन्सिडर करून सिमेट्री डिफाइन करायचा प्रयत्न करतो. त्यानंतर ब्रॅग्स लॉ आहे. सो ब्रॅग्स लॉ इज नथिंग बट वन इक्वेशन विच गिव्स द आयडिया अबाउट द इंटरप्लेनर डिस्टन्स. म्हणजे काय, तर ते ॲटॉमिक अरेंजमेंट जी आहे तर ती रेग्युलर आहे, त्यालाच आपण प्लेन मध्ये डिफाइन केलं, तर त्या 2 प्लेन मधले डिस्टन्स आहे त्यालाच आपण काय म्हणतो, इंटरप्लेनर डिस्टन्स. मिलर इंडायसेस हा सुद्धा एक पॉइंट आहे जो आपण इंटरप्लेनर डिस्टन्सच्या डेरिवेशन मध्ये यूज करतो. आणि त्यानंतर न्यूमेरिकल्स. ओके, सो हियर इफ यू कम टू दिस स्लाइड, सो आय होप दॅट यू कॅन नो दिस. आता पहिले 3 जर फिगर घेतल्या तर तुमच्या लक्षात येईल, टायटल इथे दिले बघा, सिंपल क्यूबिक, त्यानंतर बॉडी सेंटर्ड क्यूबिक, आणि त्यानंतर फेस सेंटर्ड क्यूबिक स्ट्रक्चर. दॅट इज कॉल्ड एज SC, BCC अँड FCC स्ट्रक्चर. यामध्ये काय डिफरन्स आहे, तर सिंपल क्यूबिक जो आहे इथे तुम्ही बघू शकता, सिंपल क्यूबिक म्हणजे काय, तर 8 कॉर्नर 8 atoms. बॉडी सेंटर्ड क्यूबिक मीन्स व्हॉट, 8 corner 8 atoms, 1 extra atom at the center of the unit cell. Then face centered cubic structure means 8 corner 8 atoms and center of each face, yes, is having 1 atom. क्यूब आहे, क्यूबला 6 फेसेस असतात, त्यामुळे 6 फेस सेंटर्ड atoms. तर आपला स्टडी या 3 फिगरशी रिलेटेड आहे, पण आपल्याला माहिती असावं म्हणून हे सुद्धा आपण इन्क्लूड करतो. तर हे आपण कशा पद्धतीनं डिफरन्शिएट करतो, तर लॅटिस पॅरामीटरचा यूज करून. लॅटिस पॅरामीटर्स म्हणजे काय हे सुद्धा तुम्हाला माहिती असेल मे बी, दॅट इज इंटरसेप्ट्स अँड इंटरफेशियल अँगल्स. तर क्यूबिक जर आपण केस घेतली तर त्यामध्ये काय कंडिशन असते तर दिली बघा, A is equal to B is equal to C. जस्ट अ मिनिट, आय थिंक क्यूबिक ची आहे तर ती मिस झाली आहे फिगर मध्ये. ओके, तर क्युबिकची केस काय, तर A इज इक्वल टू B इज इक्वल टू C आणि त्याचा जो इंटरफेशियल अँगल्स आहे त्याची कंडिशन काय असते, तर अल्फा बीटा गॅमा इज इक्वल टू 90 डिग्री. म्हणजे काय, तर जर 2 सेंटीमीटर असेल A, तर B सुद्धा 2 सेंटीमीटर, C सुद्धा 2 सेंटीमीटर. इट इज अ cubic one and alpha beta gamma is 90 degree, so angles are also same. Okay, but if other systems we consider, म्हणजे काय की नेचर मध्ये फक्त हे एकच टाइपचं क्रिस्टल आहे का, तर नाही. So nature is having different and varieties of materials and varieties of crystalline materials which are having different orientations. तर तेच आपण या 7 टाइप्स मध्ये डिफाइन केलं. म्हणजे वेगवेगळ्या कंडिशन्स आहेत, या लॅटिस पॅरामीटरच्या कंडिशन बदलल्या की त्याच्यानुसार हा टाइप बदलतो. Okay, so we will discuss that later on. So this we have discussed. So let us move to the next one, that is sound engineering. So as usual, give heading unit number 3 sound engineering and start writing these points. एवढेच घ्यायचे. So first give heading unit number 3 sound engineering and write down first 3.1. आता यामध्ये मी तुम्हाला सांगितलेलं की इथे 2 पार्ट आहेत, एक आहे अकॉस्टिक्स आणि दुसरा आहे अल्ट्रासाउंड. ठीक आहे, तर हे आपल्याला कंप्लीट करायचे. तर पहिल्यांदा 3.1 चे पॉइंट्स घ्या. अकॉस्टिक्स यामध्ये काय येतं, इंट्रोडक्शन, देन रिव्हर्बरेशन, रिव्हर्बरेशन टाइम और टाइम ऑफ रिव्हर्बरेशन. हे तुम्ही एक एक लिहित जावा. टेक युअर टाइम अँड राइट इट परफेक्टली. कॉमा, ऍब्सॉर्प्शन कोएफिशिएंट, त्यानंतर एक फॉर्म्युला आहे सॅबिन्स फॉर्म्युला ज्याच्यावर न्यूमेरिकल्स असणार आहेत. देन बेसिक रिक्वायरमेंट्स फॉर अकॉस्टिकली गुड हॉल. And this 3.2 is a big point, that is factors affecting acoustics of auditorium and their remedies. So write it and then go for next, that is ultrasonic. ज्यामध्ये काय येतं, introduction, piezoelectric effect and magnetostriction effect. Then properties of ultrasonic waves, then detection methods and applications. So we complete it, then we will discuss this. So everyone be sincere about the write up in the notebook, and this is the right time to complete this. Afterwards you can write it, then also it's okay, but today only you have to complete that. Otherwise if it gets pending or roughly you're writing, then unnecessarily you have to utilize your time once again. So first is acoustics. I hope that you have written the acoustics part and you are writing ultrasonic part. So if we consider first chapter, that is semiconductor physics, and second is crystallography. So I think some things are familiar to you. Is these points are known to you? Sound engineering, or first time you are facing? Sound engineering चा points कुठे होते का?
थोडे थोडे होते सर.
So everyone write this.
बेसिक इन्फॉर्मेशन होती सर साऊंडची.
हाँ, yes, काय होतं?
बेसिक इन्फॉर्मेशन अबाउट साऊंड असं होतं चॅप्टरचं नाव.
Okay, the write-up is complete. Hello.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so I think this headphone is having some problem. Not listening properly. Okay, shall we start discussion?
Yes, sir. Yes, sir.
Okay.
Sir.
Okay. Now, sound engineering means if we start with the title, so you can easily guess that it is related to sound something. Now, in that, two parts are there. First is acoustics and second is ultrasonic. Acoustics is nothing but the study of sound waves, that is originating, then propagating and receiving towards the audience. That study is called as acoustics. म्हणजे काय ध्वनिशास्त्र. ठीक आहे. Ultrasonic, if we consider, so ultrasonic is one kind of range of sound waves. त्याला आपण ultrasonic waves म्हणतो. ठीक आहे. So in case of acoustics आपण काय बघणार आहे इंट्रोडक्शन. त्यामध्ये बेसिक रिक्वायरमेंट्स असणार आहेत की एखादा हॉल किंवा एखादा ऑडिटोरियमच्या बेसिक रिक्वायरमेंट्स काय असतील. म्हणजे काय थोडक्यात तर मे बी तुम्ही एक्सपिरियन्स केला असेल की एखादा कार्यक्रम तुम्ही अटेंड करताय, स्पीच असेल किंवा म्युझिकल प्रोग्राम असेल आणि त्या हॉलमध्ये किंवा त्या थिएटरमध्ये तुम्हाला आवाज क्लिअरली ऐकू येत नाही. थोडासा इको टाईप किंवा थोडासा रिफ्लेक्टेड कन्फ्युज्ड असं साऊंड जर ऐकू येत असेल, याचा अर्थ काय तर तो हॉल किंवा ऑडिटोरियम किंवा ते थिएटर आहे तर ते अकॉस्टिकल गुड कंडिशन मध्ये नाही. सम इम्प्रूव्हमेंट्स शुड बी रिक्वायर्ड. ओके, तर त्याच्यासाठी हे सगळे पॉइंट्स आपण बघतोय. सो दिस रिव्हर्बरेशन अँड टाइम ऑफ रिव्हर्बरेशन वी हॅव टू चेक. So echo is different thing and reverberation is different thing. So echo means we are hearing that sound energy with certain time difference, and this reverberation is continuous reflection of sound through different areas from the source of the sound initially and then the different parts of the hall. त्यामध्येच काही पॉइंट्स आहेत. ऍब्सॉर्प्शन कोएफिशियंट असेल, सॅबिन्स फॉर्म्युला असेल तर ते आपल्याला बघायचे. त्यानंतर हा पॉइंट जो आहे तो 5 मार्काचा आहे. दॅट इज फॅक्टर्स अफेक्टिंग अकॉस्टिक्स ऑफ ऑडिटोरियम अँड देअर रिमेडीज. रिमेडीज म्हणजे काय, त्याच्यावरचे उपाय. ठीक आहे, म्हणजे असे कुठले फॅक्टर्स आहेत की जे अफेक्ट करतात आणि आपण ते अवॉइड कसे करू शकतो किंवा मिनिमाइज कसे करू शकतो ते आपण बघणार आहोत. नेक्स्ट पार्ट इज अल्ट्रासॉनिक. So in this ultrasonic, first is what is meant by ultrasonic waves, then this magnetostriction and piezoelectric effect. हे कशासाठी तर अल्ट्रासोनिक वेव्स प्रोड्यूस करण्यासाठी हे इफेक्ट आपण करतो. त्यानंतर अल्ट्रासोनिक वेव्हच्या प्रॉपर्टीज, त्याचे डिटेक्शन मेथड्स आणि त्याचे ऍप्लिकेशन्स. ओके, सो here if you can go to the slide. So acoustics is science related to sound, as I have told you, origin, propagation and receiving the sound waves. So next bottom figure you can see. So this is nothing but reverberation. Reverberation means what? Direct sound path from the source of the sound and the reflective sound paths or reflected sound waves from different parts of the classroom. For example, ceiling is there, floor is there and walls are there. So when we are receiving the sound energy, so it is a series of sound energy. आपण या पद्धतीने ही साऊंड्स असतात, साऊंड एनर्जी तर ती रिसीव्ह करत असतो. याच्याशी रिलेटेड आपल्याला पॉइंट्स डिस्कस करायचे. नाउ बिफोर गोइंग टू नेक्स्ट स्लाइड, कॅन एनीवन टेल मी व्हॉट इज द ह्यूमन ऑडिबल रेंज? ह्यूमन ऑडिबल रेंज
20 hertz to
20 hertz to 20.
Yes, 20 hertz to
20,000.
20,000 hertz म्हणा किंवा 20 kilohertz. Yes, both are correct. So human hearing range, if we consider this, so this is our range, that is 20 hertz to 20 kilohertz or 20,000 hertz. Now when we consider the sound waves which are having range about 20 kilohertz, then it is called as ultrasonic waves, or it is also called as supersonic.
Can you repeat your question?
What is human audible range? That is the question. So it is 20 hertz to 20 kilohertz.
20,000.
Yes, 20,000 or 20 kilohertz, whatever it is. Now we are dealing with ultrasonic waves. आपल्याला हे बघायचं की अल्ट्रासोनिक वेव्स म्हणजे काय, त्याच्यासाठीच आपण ही फिगर जी आहे तर ती डिस्कस करतोय. तर साऊंड वेव्स जी आपल्या ह्युमन ऑडिबल रेंज पेक्षा जास्त असते, 20,000 हर्ट्ज पेक्षा जास्त असते, त्याला आपण काय म्हणतो तर अल्ट्रासोनिक वेव्स. ठीक आहे. आणि the range which is below human audible range, that is below 20 hertz, is called as infrasonic waves. Okay, so all these are our possible MCQ questions, so we will discuss afterwards related to that part also. So we cannot hear these things, but some animals are having that much sensitive ears, so they can get that. Now this also you know. So if you consider first example, that is bat. So echoacoustics, that bat is using for directions and for food. Then second is dolphins. So you know that dolphins are also sending the ultrasonic signals. They are communicating and they are getting the signals. And the third one is artificial one. That is our
Sonar.
submarine. Yes, submarine, in which we are using sonar technique, that is sound navigation and ranging, and we are copying the nature and utilizing that thing. So all these parts we have to discuss in detail. Now what is the time? Still few minutes are there. So what we do, you write the syllabus of this chapter and we conclude today. So next line, give heading unit number 4. This is our last chapter for section first. Unit number 4, relativistic mechanics. Give heading relativistic mechanics. Relativistic mechanics. Give heading and write down these points. So few points are there. Few points means all are derivations related to theory of relativity. So you can write first one, 4.1, introduction, then postulates of special theory of relativity. So 2 postulates are there. Then next point, continue writing Lorentz transformation of space and time. Lorentz transformation of space and time, comma, numericals on this chapter. Then next point, 4.2, length contraction and time dilation. 2 derivations are there. And afterwards 4.3, equivalence of mass and energy, that is E is equal to mc square derivation. So continue right up. I will just check the attendance. Okay, so this write-up is completed.
Yes, sir.
Yes, sir.
Yes,
So
sir.
I have written the absent numbers. Prithviraj Kanere, are you there? Prithviraj Kanere, what is your roll number? You have not mentioned here. And Mahesh Joshi, are you there? Mahesh Joshi.
Yes, sir.
Okay, so your two logins.
Yes, sir.
Two logins are there.
सर आई एम सिंग ऑन पीसी तो उस पर माइक नहीं है इसलिए मैंने मोबाइल पर दी.
Okay, ठीक. So I will just call the absent number. Absent number फक्त मी बाकीची present लिहून घेतली. Roll number 12, 15, 17, 18, 21, 29, 36, 39, 41, 43, 49, 54, and 63. Prithviraj Kanere, are you there? Okay, please give response. 60, 61. Okay, so yes. So I hope that you have written these things. So next lecture we will start with the discussion of this interesting chapter, that is relativistic mechanics, which includes theory of relativity and it is related to mathematical derivations. So before starting these derivations, we have to understand what is meant by these terms so that you can easily get the idea about this theory of relativity. Okay, so today we conclude here. Next lecture we will start with the discussion of fourth chapter. Okay.